Welcome to day one of the Developing Science Lessons for Adult Learners discussion. My name is Heidi Schuler-Jones, and over the next 2 days, we'll be exploring inquiry-based science and rare diseases. This was originally presented at the 2019 COABE conference as part of the science strand, but for the purpose of this online forum, I've separated the presentation material into 3 parts to make it more manageable with your time and to help us organize our online conversations in the LINCS science community. You'll notice a couple of links at the top of this screen. The first one will give you access to my science materials used in this session at COABE, as well as a list of some of my favorite science resources. The second link also goes with the QR code at the top of this title slide. This code is linked to the COABE Science website that contains all the science presentations from the 2019 COABE conference. Mine was actually only one of 7 presentations, so be sure to check out the website to find even more science materials for your classroom. Before we get started, I'd like to give you some background material about the rare disease activity. Why this kind of topic and resource we'll be using is relevant to our adult education students, and where you can find a set of free curriculum supplements that can help to facilitate these types of inquiry-based exploration activities with relevant science topics. The objectives for this presentation you can see on the screen. Hopefully by the end of these 3 parts, you will have explored the use of inquiry-based science lessons for facilitating learning and stimulating student interest. And also you will have examined the application of scientific concepts to a real-life scenario involving a rare disease. I'd like you to think about, as we get started, some current news topics related to diseases as you consider the characteristics of the rare diseases. And you'll see the characteristics on your screen. There are over 6,000 rare diseases worldwide, and rare diseases affect fewer than 200,000 people at any given time in the United States, which is about 1 in 1,500. This helps to classify something as a rare disease, or sometimes known as an orphan disease. It can affect more people, but no reasonable expectation exists that the costs of developing or distributing a drug can be recovered from the sale of the drug in the United States. This is actually part of the Orphan Drug Act of 1983 and was used to help classify when something was declared a rare disease. A rare disease also includes disorders and symptoms that vary not only from disease to disease, but also from patient to patient. And this can make it really difficult for the classification. 80% of rare diseases have identified genetic origins. Others are the result of infections, whether they're bacterial or viral, and then still some others are caused by the environment. 50% of rare diseases affect children. And the common symptoms that present themselves with a rare disease can hide underlying rare diseases, leading to misdiagnoses and delaying the treatment of the patients. Rare diseases may become common, and common diseases may become rare. And so I'd like you to think about, as you listen to those characteristics, if there are any recent news reports about this last item in the list. Rare diseases may become common, and common diseases may become rare. Has there been anything in the news lately that comes to mind? For example, you may have heard recently some news reports about measles outbreaks, not just in the United States, but in other countries as well. We've also recently heard about polio returning in some countries, and the Zika virus and Ebola virus also are very common in our news today, particularly as we're ending summer with the Zika virus and mosquitoes. This information, by the way, you can get from the link that's at the bottom of your screen, and you can learn a good bit more about what makes an orphan disease orphan. There's also a rare disease day, and on this website that you see, the link at the bottom, you'll find out more about it, but the first rare disease day was actually celebrated in 2008 on the 29th of February, which is a rare date that happens once every 4 years. And ever since then, Rare Disease Day has taken place on the last day of February, a month known for having a rare number of days. The Rare Disease Day takes place on the last day of February each year. The main objective of Rare Disease Day is to raise awareness among the general public and decision makers about rare diseases and their impact on patients' lives. And building awareness of rare diseases is so important because 1 in 20 people will live with a rare disease at some point in their life. And despite this, there is no cure for the majority of rare diseases, and many of them go undiagnosed for a lot of the reasons we looked at with the characteristics. So why is this relevant? Why is this topic of rare diseases relevant to adult education? Well, it's not just about the science test on the high school equivalency exams. It's also about preparing our students to improve reading and writing skills, to increase their use of sound reasoning, and interpret meaning from graphs, charts, tables, and all sorts of visual models. And fortunately, the scientific content in studying rare diseases offers opportunities to develop these skills, all within a context that is relevant to the lives of our students and the communities in which they live. According to the GED testing service, students need to understand science concepts. They need to know how to read graphs and charts displaying scientific data, and they need to use reasoning to interpret scientific information. And the primary focus of the GED test, science GED test, is the measurement of essential reasoning skills like analysis and evaluation and inference. And all of this has to be applied in a scientific context. The science content topics describe key concepts that are widely taught in a variety of high school level courses and are relevant to the lives of GED test takers or high school equivalency test takers. The content topics provide context for measuring the skills outlined in the science practices. Here's a sample GED science question. And you'll see as you look, just kind of glancing over, it's about a very relevant topic most of us have experienced, and that's chickenpox. This question asks you to use the data presented in the graph to support a given conclusion about a vaccine and its relationship to chickenpox. The varicella is a virus that causes the disease chickenpox. Medications are used to treat the symptoms of fever and discomfort associated with chickenpox. In 1995, a varicella vaccine was made available to people in the United States. And the graph that you see at the bottom shows the number of chickenpox cases reported in 4 U.S. states from 1991 to 2007. And as you read through that information and you take a look at the graph, what could you imagine students being asked to identify or evaluate or being measured by this question? What kinds of information might our students be tasked with knowing and learning? What kind of resources are out there that can help us to meet the requirements for analyzing data, evaluating information on charts, tables, and graphs, and applying it to real-world context? What kinds of things are out there that make sense to our students and can be of interest to them? This free set of titles from the National Institutes of Health curriculum series is useful for ABE to ASE level students. It explores the science behind health topics like sleep disorders, evolution and medicine, and addiction and the brain. The materials use actual biomedical discoveries and real scientific data to facilitate critical thinking, develop teamwork, reasoning, and problem solving between our students. And the content is fully aligned to both the National Science Education Standards and the State Education Standards, though you'll need to do some cross-referencing for the exact numbering for the College Career Readiness Standards in Adult Education. Each of the curriculum supplements comes with a complete set of printed materials for teachers, including extensive background and resource information. So if you're not someone who has spent a lot of time looking at science or studying science and you need to beef up your own understanding, all of the material is part of this curriculum supplement series for you as well as for the students. It also includes detailed lesson plans and Blackline Masters for student worksheets. It also has an online component that we'll be exploring as we get into part 2. And many of the books also contain online and interactive materials to support the lessons. These supplements are distributed for free to educators across the United States upon request. You can copy them for your classroom use with no copyright issues to worry about, as long as it's for educational purposes. And the best part about it, even more so than them being free, is that students actually are eager to learn from these resources. And just as a side note, this was really written for K-12, and so you'll see the 16 titles broken into elementary, middle, and high school levels, but it's easily adapted to our adult learners, just with some language shifting from kids to students. It generalizes it enough for our students. And the reading level that's separated for elementary and middle probably applies to our ABE 1 to ABE 4 level students. The high school content has a pretty high vocabulary, so a higher reading level would probably be needed for the high school level materials, unless you do some adaptations for it. So here's a look at some of that learning in action from my own classroom and some of their favorite resources. This is a set of pictures from a couple of my students' favorite lessons and activities. You notice the chicken bones and the pasta pictures. These are from the resource called Looking Good, Feeling Good from the Inside Out, exploring bone, muscle, and skin. And these were two activities as part of one particular lesson that talked about bone density and collagen. And it was a really fun activity, had lots of math included in it. So it's a great one to split between math and science time if you need to teach those. You'll also see in the top right, these are radish seed pictures. They are radish seed germination, and it's from a resource called Chemicals, the Environment, and You, Explorations in Science and Human Health Activity. This particular lesson, we grew them in our computer lab where there were no windows, there was no natural sunlight, it was just fluorescent lighting, and the students actually in 3 days' time could take pictures of this, and they came back on their days off to see how things had progressed. They had a science lab book where they took notes on what they observed and sketches. Many of them took pictures with their cell phones and shared the pictures with their lab partners who were not tasked with coming in that day to take notes on the experiment. Every lesson in the books, every lesson utilizes basic concepts in the science. And this one was on toxicology in particular. It made it very accessible to ABE students, and it was a lot of fun to put together as well. One of my ASE students, high-level students, really got interested in one of the high school level books called The Brain, Understanding Neurobiology Through the Study of Addiction. And she was particularly interested in it because it was very personal to her. She was 1 year into her 2-year drug court ordered recovery program and was able to speak quite candidly about her own experience of addiction. By the end of the lessons in that series, she felt like she was better able to understand the science behind why it was so hard for her and others to stay clean. And she even commented that she'd been sharing what she'd learned at her group meetings each week. So again, finding meaningful real-world context can make a difference in helping students to attain those skills that we talked about earlier. And engaging with this material goes well beyond any test. It continues to motivate our students to become lifelong learners. So one of the main objectives of the resource we'll be using today, or with this presentation, is to help our ABE students in particular understand that universities and companies and agencies studying rare diseases are not only important to the patients and their families, but it also helps researchers to apply their discoveries to other more common diseases, or more generally to how the body works. And another objective to help our students experience the process is to help our students experience the process of scientific inquiry through activities related to rare diseases. And the lessons that are in this supplement help students sharpen their skills in observation, critical thinking, experimental design, and data analysis. They also make connections to other disciplines such as English, mathematics, and social science. And if you're not sure how this might fit into your science curriculum, lesson 2 that we're about to do from this book correlates to these scientific inquiry topics. Testable questions can be answered through scientific investigations. Scientific investigations use appropriate tools to gather, analyze, and interpret data. Evidence is used to develop explanations and make predictions. Critical thinking is used to relate evidence to explanations. Alternative explanations are recognized and analyzed, and mathematics is important to scientific inquiry. How does the Biological Sciences Curriculum Study 5E instructional model promote active, collaborative, inquiry-based learning? The lessons in this supplement use a research-based pedagogical approach called the Biological Sciences Curriculum Study 5E instructional model, or the BSCS 5Es. The BSCS 5Es are based on a constructivist theory of learning, and a key premise of this theory is that students are active thinkers who build or construct their own understanding of concepts out of interactions with phenomena, the environment, and other individuals. A constructivist view of science learning recognizes that students need time to express their current thinking, interact with objects, organisms, substances, and equipment to develop a range of experiences on which to base their thinking. They need time to reflect on their thinking by writing and expressing themselves and comparing what they think with what others think. And they also need time to make connections between their learning experiences and the real world. The BSCS 5Es sequence the learning experiences so that students can construct their own understanding of a science concept over time. The model leads students through 5 phases of active learning that are easily described using 5 words that begin with the letter E: engage, explore, explain, elaborate, and evaluate. In the lesson 2 that we will examine, we will actually be focusing on explore, the explore phase of the 5Es. And rather than just listening and reading, students are also analyzing and evaluating evidence. They're experiencing it, and they're talking with their peers in ways that promote the development and understanding of key science topics and concepts. These inquiry-based experiences include both direct experimentation, like we did with the radishes and the chicken bones in the pictures you saw. It also includes the development of explanations through critical and logical thinking. Students often use technology to gather evidence and mathematics to develop models or explanations. The BSCS 5E emphasize student-centered teaching practices. Students participate in their own learning in ways that are different from those in a traditional classroom. So, that's the end of part 1. I invite you to consider the topics that you see on the screen and what we're going to be doing and gaining from this instructional model as we go into part 2 of the activity.